Okay. Good afternoon, I'm Pietro Novero, and I come from the University of Calabria, and I want to present you the work named the Tribological properties of wear-resistant coatings obtained by Gold's dynamic spray. So Gold's dynamic spray is a new recent coating deposition technology in which very small particles with a diameter of around 45 microns were accelerated by a supersonic gas jet, in general nitrogen or helium. So the particles undergo large plastic deformation and consequently adiabatic shear instability leads to the friction and the flow material for bonding of the particles on the substrate. The aim of this work is obtain good deposits of stellite 6 by galvanic spray in terms of low porosity and good adhesion and cohesion for improve the tribological properties of a steel surface in general. The characterization was carried out on the micro scale by using a micro indenter, and the tribological properties was analyzed by a pinot disc test. The evaluation of the quality of the coating was carried out using microscopic observations. So the high-pressure cold gas dynamic spray equipment was an impact spray system 511 by Impact Innovation, and was used a commercial stellite 6 powder with a particle size of around 40 microns. At first was investigated the thermomechanical parameters, in particular the gas stagnation temperature in the range of 800 degrees, 970 degrees, and gas pressure in the range of 35 to 45. The other mechanical parameters were kept constant, in particular traverscan speed equal to 300 millimeters per second, and the standoff distance equal to 20 millimeters. On the basis of the microscopic observation was selected the higher values of the thermomechanical parameters investigated, and so suggest that maybe better results in terms of low porosity could be obtained increasing these parameters, gas and pressure and gas pressure. In fact, the loadability of stellite 6 requires very high impact velocity to obtain the high deformation needed by a good coating. On the microscale, the characterization was carried out by micro-ardent measurement of on the top surface, and we reached mean value of 700 beakers, but was obtained also a very high coefficient of variation around 0.2. And this can be attributed to the different loads path of each particles from the gun nozzle to the impacted surface. Moreover, the local morphology of the impacted zone, the hardness, the different hardness of the impacted zone can be influence the results of the coatings. In particular, was analyzed also by microscopic observations the image of the indents. In particular, the indents carried out on a porosity-free zone could be represented a zone in which the mechanical properties are good. But the indentation near the crack in the splat boundaries can be demonstrated that the crack boundaries can be a weak point of the coating. But if the indents were carried out near a local porosity, we can observe a larger indent area and consequently local hardness very lower than the other zone of the surface of the coating. Another kind of characterization was carried out on the cross-section of the coating in order to analyze the equation properties of the deposited layers. At first, in fact, was analyzed the local effect, and were carried out 5 indentations for each lot level. And we can observe that increasing indentation was the micro hardness decreases. So we can see that the indentations involve more splat boundaries. So for this reason, we have set the applied load used for the characterization equal to 1000 millimeters. In fact, when the indentation was carried out near a zone in which the cohesion strength is high, the splat boundaries seem not damaged, but in some cases the bonding mechanisms can be observed induced by indentation, and it suggests that the cohesion of the splat boundaries in this zone is low. In fact, in this zone, a pronounced increase of the indentation depth was measured for the indents affected by coating porosity and particle outer bonding. On the other hand, the analysis of the micro hardness and of the reduced Young's modulus was carried out on the cross surface as a function of the coating depth. And we can observe that increasing micro hardness and Young's modulus increase with the depth coating. This observation suggests how the single deposited layers is affected by the properties of the impacted surface. But the value of the Young's modulus of the coating near the interface between substrate and the first layers of coating is strongly affected by the mechanical properties of the steel substrate. And this higher value can be attributed to the impact of the subsequent layers of the other layers and to the different interaction between coating, between the first layer of coating and the substrate. On the other hand, was carried out a tribological experiment, tribological experiments using a pin-on disc standard method, and for the case was prepared some samples characterized by a grinded surface. The tests were carried out using a 6 mm alumina pole with a sliding distance equal to 0.06 meters per second, a track radius equal to 12 millimeters, and a sliding distance equal to 1,000 meters. In particular, were evaluated two levels of the normal force, 5 Newton and 10 Newton. So we can observe the more or less the same behavior in the trend of the friction coefficient. In fact, the mean value of the friction coefficient does not show significant difference for each test. And this suggests that probably oxidation phenomena do not occur during the test. So the sample wear rate was evaluated on the basis of the mass of the volume mass loss obtained by profilometer measurements, and in particular was observed a very higher value of the sample wear rate in the test in which the applied load is equal to 5 Newton. In fact, this is due to the local damage observed also before during the indentation test. In fact, on the wear track observed for the test carried out under a load equal to 5 Newton, the pull-out phenomena can be observed. But in the wear track of the samples tested under 10 Newton load, the surface seems to be less affected by this kind of phenomena. In conclusion, gold gas dynamic spray has been demonstrated to be successful to produce elite coatings, and the high values of surface microhardness were reached thanks to the large plastic deformation and hardening occurring during the particle effect. In particular, was obtained a mean value of the microhardness equal to 700 pickers. But a significant variability obtained is attributed to the local mechanism related to the non-homogeneous mechanical properties. In fact, the spot boundaries can represent a weak point of the coating. On the other hand, the friction coefficient is not affected by the applied load in the range 5-10 Newton, and its low value around 0.5 suggests that gold gas dynamic spray can be used in the anti-wear application. And the variation of the wear rate with the applied load can be attributed to the local mechanism. In fact, the pull-out phenomenon observed, the pull-out phenomena can be observed only in the test in which the load is equal to 5 Newton. Thank you for your attention.
Thank you.